Caffeine, everybody's favorite molecule to stay awake while studying. We're going to use caffeine as an example in this problem where we're going to use these mass percentages to go to empirical formula, and then separately we're going to use these mass percentages to figure out the empirical formula of caffeine, and then after that we're going to figure out the molecular formula of caffeine. So how do we go from mass percentages to empirical formula? There's kind of a step-by-step procedure that I use, and I think it's pretty helpful, so I would suggest using it, but if not, obviously there's other ways to do it, but this is what your book suggests, and this is also what I suggest. So if you have these mass percentages, how do you figure out the empirical formula from these percentages? Well, the first thing I do is I pretend I have 100 grams of my compound. And then if I have 100 grams of the compound, then that means I had 49.48% of that's carbon. That means 49.48 grams of carbon is how much I will have. So my first step is I convert each of these percentages to grams, pretending that I have 100 grams. After I have all of the percentages turned into grams, then you need to convert from grams to moles. And this conversion factor is just like any other gram to mole conversion. You have to use the average atomic mass. So to convert from grams of carbon to moles of carbon, and 1 mole, and yeah, I should write carbon, but just to save room, I'm going to abbreviate here. I have 12.011 grams. For 5.15 grams of hydrogen and 1 mole of hydrogen, I have 1.0079 grams. And 1 mole of nitrogen, I have 14.01 grams. And in 1 mole of oxygen, I have 15.999 grams. Now you do your math. After you perform all of these calculations in your calculator, you'll end up with the following amounts of moles of each compound. So that's moles of carbon, moles of hydrogen, moles of nitrogen, and moles of oxygen. The next step says we want to find the lowest common factor of all of these. So we want to turn them into the smallest ratio possible. So to do that, you divide each of them by whatever number is the smallest out of this group. Meaning this 1.031 is the smallest out of the group. It's the smallest of the ratio. So we divide each one of these entities then by 1.031. And that should give us whole numbers. So we get 1 for this. For the rest of them, we get 4, 5, and 2. Now, you may not exactly get 4. It may be like 4.001 or something like that, but you're trying to get it close. If it's close, you just round it. If it's not close, if you end up with like a half, or you end up with a third, then you can assume that this number its subscript in the empirical formula is not a 1, this one would be 2. And so you're just figuring out ratios. So if this is a 1, then this is 4. But let's say this was like 4.5. Then what that tells me is this is really 2, and this is 2 times 4.5, which would be 9. And so you're just trying to turn these into a ratio. However you need to do the math to make that work, that's how you do it. But in the end, what do these become? These become the subscripts in the empirical formula. So my empirical formula for caffeine is C4H5N2O. And you can put the 1 or you could leave it. So that is my formula for caffeine. But now let's pretend we know our molecular weight of caffeine. Is this the empirical formula and the molecular formula, or is it just the empirical formula and we need to figure out what the molecular formula is? For the second half of this problem, we are given this information. Our molecular weight of caffeine is equal to 194.2 grams per mole. Now, how you start out this problem is by first asking the question, if that is my molecular weight, then the mass of this compound should equal this. So calculate what the molecular weight of this compound is. That should be the first step. So this compound has a mass of 97.04 grams per mole. That tells me that this formula is my empirical formula. All right. So then in order to calculate, all right, what's my molecular formula then? I need to see how is this mass related to this mass. And so in order to do that, I take my 194.2 and I divide it by 97.04. And I get approximately 2. What that tells me is the subscripts in this equation need to be multiplied by 2 to get me to my molecular formula. So if I multiply all of those subscripts by 2, I get C8H10N4O2. And that is my final molecular formula. So this is my molecular formula. So if you're ever asked to calculate the molecular formula from mass percents, you now know how to do that. You first turn them into an empirical formula and then use the molecular weight of the whole compound in order to calculate that molecular formula.